You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we focus on the essential programming skill of debugging, finding, and fixing errors in code, and how to interpret program logic to understand what a program is doing. Debugging is one of the most common activities in programming and one that requires strong logic and reasoning skills. We'll explain how to identify different types of errors, read program flow, and understand how Boolean conditions affect outcomes. This content is found in Domain 4 of the Information Technology Fundamentals Plus exam. On the ITF Plus exam, you won't need to write or fix code, but you may be presented with program scenarios and asked to identify the likely source of a problem. For example, you might see a question that describes unexpected output and be asked to choose the most probable reason. Understanding debugging concepts and how logic flows through a program helps you analyze these situations. This episode focuses on recognition and logical interpretation, not technical coding. Debugging is the process of identifying and fixing problems in a program. These problems, also known as bugs, may prevent the program from running, cause incorrect results, or disrupt the expected flow of execution. Debugging includes reviewing code for syntax mistakes, incorrect logic, or unintended behavior. It's a step-by-step process that helps programmers ensure the code works as intended. Even simple programs often need debugging during development. Program errors usually fall into a few categories. Some are caused by incorrect logic, such as using the wrong condition in an if statement. Others may involve missing values, such as forgetting to initialize a variable. Unexpected input can also cause a program to behave incorrectly if it's not handled properly. These common issues can be isolated and corrected through careful review and testing. There is an important distinction between syntax errors and logic errors. Syntax errors occur when the code breaks the rules of the programming language. These errors prevent the program from running and are usually flagged with clear messages. Logic errors, on the other hand, do not stop the program from running, but produce incorrect results. Logic errors are often harder to detect because the code appears to function but does so incorrectly. Debugging tools include basic methods such as using print statements to display variable values and checking code line by line. These techniques allow programmers to observe the internal behavior of a program as it runs. Output tracing, or following the flow of output, helps verify whether the program logic is executing in the correct order. These approaches are simple but effective, especially for small programs or beginners. Interpreting output is a key part of debugging. This means comparing what the program actually does against what it was expected to do. By checking variable values, conditional outcomes, and loop behavior, users can often identify the exact step where the code diverges from its intended path. Exam questions may describe an unexpected output and ask you to trace it back to a faulty condition or logic step. Understanding program logic flow means being able to read code and follow its structure. This involves recognizing what each line is trying to do, how data moves through variables, and what conditions affect program behavior. For example, a student might be asked to look at a sequence of decisions and determine which path would be taken with specific input. This type of analysis helps clarify whether the logic is working correctly. Boolean conditions play a major role in program control. These include if statements, else blocks, and while loops that depend on true or false evaluations. Errors often arise from misusing Boolean operators or misunderstanding how they interact. For example, using or instead of and can cause a condition to evaluate unexpectedly. Debugging such issues requires reviewing how conditions are written and what they are supposed to achieve. Using test inputs is a reliable method for debugging. Feeding sample data into the program helps confirm whether each part behaves as expected. By changing the inputs and observing the results, developers can isolate which conditions or branches of code are causing issues. This practice is often used to catch edge cases or hidden bugs that don't appear during normal use. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One of the simplest strategies for fixing code errors is to break the code into smaller, testable parts. By isolating sections of the program, you can focus on each part individually and observe its behavior without interference from the rest of the code. Adding print statements can also help track how variables change, which conditions are triggered, and what the program is doing at each step. In some cases, commenting out parts of the code temporarily can isolate the issue and narrow down the root cause. Logic errors are often the most difficult to detect because the program runs without crashing. Instead of producing error messages, the program produces incorrect results. These errors may only show up when certain input is used, or when a specific condition triggers an unexpected path. Fixing them requires a careful reading of both the code structure and the output to understand why the logic didn't work as intended. The ITF Plus exam may use terms such as unexpected result, error message, or incorrect output in questions that reference debugging. These clues point to common program behaviors that require analysis. The exam will not ask you to correct code, but it may describe a bug and present answer choices that suggest likely causes. For example, the test may ask why a program returns a value of 0 when a different number is expected. Interpreting multiple logic paths is another important skill. Programs often use if-else structures or switch statements to determine what actions to take based on user input or calculated values. During debugging, it's important to trace each possible path and confirm whether the correct branch is taken. When loops are involved, you should follow each iteration to see how variables change and when the loop ends. This methodical approach helps verify the overall behavior of the program. Understanding the structure of a program is key to identifying logic errors. Many bugs are the result of incorrect sequencing, missing steps, or overlooked conditions. Being able to read a program's structure, its loops, conditions, assignments, and output statements helps you anticipate what it should do. If the actual output doesn't match the expected result, something in the logic or sequence is probably misaligned. The ITF Plus exam may include questions such as, "Why is this program showing the wrong result?" or "What part of this flow might fail under certain input?" Other questions might show a block of pseudocode and ask which line is most likely responsible for a given error. These questions test your ability to trace logic, understand Boolean conditions, and spot inconsistencies in program behavior without requiring any actual coding. Terms you should know for this topic include error, bug, debug, logic, output, expected versus actual, trace, and fix. Each of these terms relates to a specific part of the debugging and logic interpretation process. For example, trace refers to following the program's execution step by step, while expected versus actual output helps identify discrepancies that indicate a logic error. Memorizing these terms will help you navigate related questions on the exam. The ITF Plus exam does not require the use of debugging tools, such as breakpoints, watches, or integrated development environments. You also won't need to interpret syntax error logs or run real programs. The focus is strictly on high-level understanding, being able to describe what debugging is, how logic errors differ from syntax errors, and what strategies are used to find the root of a problem. This episode ties directly into earlier content on programming logic, loops, branching, and Boolean operations. Debugging and logic interpretation are the natural follow-up to those topics. You are now applying everything you've learned about sequence, conditions, input, and flow to understand not just how code is written, but how it behaves. This reinforces your understanding of cause and effect in programming and helps build a more complete mental model of how software works. To summarize, debugging is the process of finding and fixing problems in code, while logic interpretation helps explain why a program behaves a certain way. Syntax errors prevent a program from running, while logic errors cause incorrect results. You may be asked to recognize terms, identify the likely cause of a bug, or follow logic through a program description. Mastering these skills completes your foundational programming knowledge for the Information Technology Fundamentals Plus exam. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.